Okay, so looking at numbers 2, and hopefully I can do this quickly and get to number 3. I will tell you this, we're going to look at number 2, but the problem on the test that I have for you is not quite as difficult as this one. And since there's only a few problems like this, I made the executive decision to change that. But I want to just kind of go over it quickly, just so you can get an idea what it is we're doing here with this piecewise function, which you have these 3 pieces, so to speak. So looking at this, you have g of x, which remember our function notation, that's like our y equals -2 if, now here we have a little bit more than just like we had above it, where x is greater than or equal to 1, but less than 3. So that's not a very big piece, and I'll show you that on the graph. And then we also have g of x equals -x plus 4, only when x is less than 1, but greater than or equal to -1. And then lastly, g of x equals 3 or y equals 3 if x is less than -1. So let's look at the first two, which I'm kind of looking at like this, y equals -2 and y equals 3, when this one is 1, x is greater than or equal to 1 but less than 3, and then this one is when x is less than, I'm rewriting this for some reason. Okay, so we're gonna graph that. So y equals -2. Now if you think of that, and you know this, it's just something that you haven't really known very long, y equals gives us a zero slope line, which is a horizontal line. So this would be a horizontal line at -2. So if I was going to graph it, I'm going to go down to -2, and if it was just simply y equals -2, that would be the line for that equation. But since it had some requirements wrapped around it, that x had to be less than 3. So here I am at less than 3, and it's an open circle. I'm sorry. It's an open circle. That x had to be greater than or equal to 1. So here's 1, and it's solid. So this is a horizontal line, but only this little piece of it. Kind of weird, but that's this little piecewise, okay, of this function. And then let's go to g of x equals 3, or y equals 3, again, would be a horizontal line at x equals 3 if we didn't have the rules applied to it. So this is x has fallen, where am I? Less than -1, not equal to -1. So I went up onto y equals 3, went to -1, x equals -1 is here, and I put an open circle there, and I went less than this way. So far our graph is this and this little piece right here. And so the last thing that we have is -x plus 4 when x falls in between 1 and -1. Okay, so let me just kind of put that one over here. So we have -x plus 4, and so x is greater than or equal to -1 but less than 1. So if I'm going to think of a table, well, what values do I have? Well, let's put 1 in here. Even though it doesn't equal 1, I know I'm going to have an open circle there. And so x is less than 1, but it's greater than -1. So let's put 0 and -1. So that's basically the 3x values that we can have here. So let's plug in 1. -1 plus 4, that's going to be a positive 3. Plug in 0 here, that's going to give me 4. The way it looks, this is going to be 5 if I'm doing everything right. -1 is a positive 1 plus 4 is 5. So if I go and graph these 3 pieces, these 3 points, okay, I'm going to go 1, 3. So here I am, 1, 3, but I'm going to go open circle because it does not equal 1. And then I'm going to go 0, 4, solid.
Someone from maintenance, please report to the office. Someone from maintenance, please report to the office.
Maybe you heard that. And -1, 5, which is right here. And so there is my graph there. So I have these 3 pieces of this situation graphed. And so if we wanted to look at the domain and the range, which we're being asked, and this is kind of funky, this gives us, notice I'm looking at my domain, which is my X values. This, I see this arrow right here, it's going on and on to the crack of dawn. So that's going that way. If I look at the positive side of things, what's happening here? It stops here at 3. So I know that my part of my domain is going to be, X is going to be less than 3. Okay? It's going to be less than 3. There's nothing that goes more than 3, and we're not including 3 because of this right here. So the domain X is less than 3. All right, so our range, this is kind of weird because we have, so you have this, and we have this, and you have this little weird thing. These are weird, and in the book didn't give us a lot of examples like this, which I kind of find odd because they typically haven't been doing this on the test where they dump a crazy advanced problem after not practicing problems like this. So this is y equals -2. That stands for that one. This is going to be something, like X is going to be less than 1, but greater than or equal to -1. Okay, so like I said, we are not going to have this problem on the test. I don't think it's fair, and I don't think we practiced that enough. It's pretty crazy what we did here, and I know that you could handle it if we had practiced it more. But I've put one in there that is much more like the examples on page 219. The video that we watched, very similar to that, much more reasonable. Okay, number 1 will still be on there for sure, one like this one. This one, I'm going to kind of lighten the load of it. Number 3, we did in class today. So I'm going to try to, I think that's all that I have left to go over. Oh, since I'm just the end of this video, I just wanted to talk to you about this. 17 and 18 on your review, which goes along with the scatter plot and the line of best fit. It has you doing 2 things. Okay, where it had you take it, graph it, come up with your line, pick 2 points, find the slope, go through all that to come up with your equation of the line, the best model that you can create. Well, that's a lot of business going on and a lot of work, and we can do it, but we also have the technology and the capabilities to use our calculator. So I've changed the problem that you see here. It's not 2 problems. So you're going to have a similar thing with a graph and a table, and you're going to have similar. I'm going to kind of point out the questions. You're going to have to talk about the correlation between the 2 things. In this case, it was the amount of study time versus the grade that you're getting. So the more you studied, the higher your grade was our correlation. You're not going to do this without a calculator. You're definitely going to have to talk about the slope and the y-intercept. The slope in this case has to do with, for every hour that a person studies, that's the movement up, because I know it's going up, because our slope's going like this, because it's positive, and the more you study, the higher your grade. So whatever your slope is, that means that every extra hour we study, there's that many more grade or percentage points higher. And the y-intercept would be where you started, if you never studied, what the grade would be without studying. Okay, kind of our starting point. And it kind of makes sense in this case. You can see here where this person didn't study, they got a 60%. I believe when you do it on the calculator, it comes out very close to that. So yep, you'll do this. The correlation coefficient, you're going to definitely talk about that. Your R, so you have to go to diagnostic on your calculator if it's not on. Okay, and identifying, interpret it is tell me what it is. Is it positive or negative? And is it a good correlation or not? And you know if it's 0.9 something, especially if it's above 0.95, you know that it's a strong correlation. Okay? And then part C, you're going to have to do something like this where using your data from your calculator and maybe the table here, give a prediction using your model. If a person studies for 3 hours, you could plug it right into the actual equation you get from your calculator to see what kind of different score you get here. It's probably going to be very similar to 3. We have 2 3s on this table, and if I ask you the same question and you used your equation from the calculator, you're going to probably get something a little bit in between both of these. So I've changed this. You're going to be doing definitely less on your own and using your calculator to help you with this. So keeping that in mind, practice that, okay? And then when you come in tomorrow, if you need to talk to me before we take the test, if you need to talk to me in the morning, you need to seek me out so we can talk about that. And we may have time tomorrow because it's Weird Wednesday day, altered schedule day, web day, Moby Max day, whatever we call it. All right, good luck, study. I'll talk to you tomorrow. I'll talk to you soon.